Okay, now let's look at how we can evaluate double integrals. And first we're just going to do it over a rectangle. So how to evaluate double integrals on a rectangle. So let's say our region is this is x, y-axis. And we're going to go from the rectangle A, B, and C to D. So this is our region here. We'll call it capital R. Now, if we integrate, we can integrate from C to D, A to B, and that's going to be the same as C to D, A to B. If F is continuous on the rectangle. So those two are equal. So what's that telling us is that the order of integration doesn't matter. We could do x first or y first. And I'll show you that in this example. Suppose my rectangle is 1 by 3, is 1, 3 by negative 1, 2. So this is my x boundaries, and these are my y boundaries. And my function, let's say, is 3x squared plus 2xy cubed. So first I'm going to integrate with respect to x, and then with respect to y. So when I do this with respect to x, it's like holding y constant, just like with partial derivatives. So let's say hold y constant when we do it with the x. And I'm not going to put an equal sign here because it's not going to be equal. I'm just going to do this right here. And that's going to be the integral of 3x squared is x cubed. And here x, and the 2y cubed is a constant, so I have 2y cubed, and I'm just integrating x, which is x squared over 2. And then I'm going to evaluate that from 1 to 3. So now that's equal to x cubed plus the 2's cancel, x squared y cubed, 1 to 3. Now since I was doing it with respect to x, dx, these are x values. So I'm going to plug those in for x. I get 27 plus 9y cubed minus 1, and plug the 1 in for the x, plus y cubed, and that's going to be 26 plus 8y cubed. Okay, so that, then I'm going to take that and integrate with respect to y. So that's this part. So now I'm going to integrate from negative 1 to 2. 26 plus 8y cubed. Notice I don't have an equal sign there. These are just notes, so only put equal signs in when things are equal. Be real careful about that. Now when I integrate with respect to y, x is constant. Well, I don't have any x's here, so this is 26y plus y to the 4th over 4, but I'm dividing by 8 by 4, so that's going to be 2. And I'm going to evaluate that from negative 1 to 2. And these, again, since I'm integrating with respect to y, these are y values. So I'm plugging those in for y. And I get 52 plus 32 minus a negative 26 plus 2. And when I add all that up, I get 108. Okay, now I'm going to do the same problem and reverse the order of integration and show you that you get the same answer because my function is continuous. So now I'm doing this part. X, we hold x constant, Okay, now don't write equals there because that's not what this double integral is equal to. We're only doing that single integral. So with x constant, we have 3x squared y plus 2x y to the fourth over 4 from -1 to 2. Okay, now substituting 2 in for y because these are y values. I get 6x squared plus half x times 16 minus, now I'm substituting -1 in for y. Okay, simplifying that, I get 9x squared, and that's 16 over 2 minus half, so that's 15x over 2. Now I'm going to integrate that with respect to x. So I have the integral x equal 1 to 3. And that's going to be 3x cubed plus 15 x squared. And that's going to be 81 plus 135 fours minus 3 plus 15 fours. Okay, that's going to be 81 minus 3 is 78 over 124, so that's 30, so that's 108. Again, so you see we get the same answer as long as our function's continuous. Now, let's go to Maple and see how we can do this in Maple. What you need is the student package, so we're going to do with student. And the command we're going to use is double int, which is double integral of 3 times x squared plus 2 times x times y cubed. And x is 1 to 3, and y is -1 to 2. And you see that it'll give us that double integral, dx dy. And all we have to do is say value. Percent gives us the last command that we've typed. So we want the value of that double integral, and it gives us 108, which we knew because we did that problem. Okay, now I'm going to switch the variables. So wherever there's x, I'm going to put a y. Wherever there's a y, I'm going to put an x. So because this double integral just does dx dy. So the command, I'm going to just copy this so I don't have to retype it. I'm going to change the x to y and y to x. So now first I'm going to go from -1 to 2, and that's like y going from -1 to 2 because we switched variables, and y is going to go from 1 to 3. So I switched the integral and I do value and I get 108 again. So that the only bad part about double integral, you have to do x first and then y. It doesn't reverse. Okay, so that's a good check. You can use that to check your homework problems. All right, let's get back to here. And what you can do is look at the example homework problems for some more examples.